Hey everyone, hope you had a good spring break. Hopefully you got some good rest. Maybe you did some fun stuff with your family or whoever, but hopefully you guys got a good break out of our spring break. We are going to be jumping right into the next unit, which is conics, and I'll be showing you why this section is called conics. Once we get through all of them, I'll kind of bring it back, and if you had me in Algebra 2, actually, you've probably already seen this. I'm pretty sure I did it this past semester. But there is a reason that these shapes are called conics. We're going to be taking a look at circles, parabolas, ellipses, and hyperbolas. Alright, and so today we're going to be focusing on circles. Next we'll be looking at parabolas, and then we'll take a look at the others as well. So, hopefully along the way in your math career you have seen, the equation of a circle, maybe in geometry, Algebra 2, but we want to be familiar with the standard form equation, so that's what I have right here. X minus h squared plus y minus k squared equals r squared. Alright, and here we have a picture of a circle, and let's just talk about the different parts of a circle. So, we have the center, and now we're going to refer to the center as a point, and that point is a coordinate. So, instead of calling it an xy coordinate, we're actually going to use h and k, and that's what we're going to do going forward with all of our conics. All right. Then we do have a point out here on the circle, and this could be any single point on the circle. It doesn't have to be this one, but any point on the circle would be an xy coordinate. So we do use x and y for that. And then we know already that anytime we have the center or the distance from the center to any point on the circle, and on a circle it's going to be the same distance all the way around. And we call that the radius, so we're going to use r for radius. Okay. So the very first example that we're going to be taking a look at, we have a point. All right. So we have example 1. And we have a point on the circle, which is 1, 4. Alright, and then we're also given a center, which is -2, -3. And what we want to do is, only with this information, we want to find the entire equation of the circle in standard form. There's another form that we'll see later on. But right now we want to put this in standard form, and there's a lot of reasons for that. We can very quickly identify the center and the radius of a circle, and so when we can quickly identify information, that's always a good thing. Alright, so we are going to go ahead and start with this equation. So we have x minus h squared plus y minus k squared equals r squared. Alright, so if you remember, this point, right, going back to our diagram, is an xy coordinate. So we could just plug in this xy coordinate in for x and in for y. Remember that the center is another coordinate, but we call it specifically the h and k coordinate. Alright, so the first one would correspond to h, and the second one would correspond to k, and we can just plug that in right here. Alright, and then, because we'd have no more variables here, we could actually solve for the radius, and once we do, we have every single piece of information that we need to write an equation for this circle. Alright, so let's go ahead and do that. So in for x, I'm going to plug in 1. And I'm going to do this one at a time, one piece at a time. So my x, and then I'm going to plug in my y, so that's 4 right here. Okay, I'm going to bring down those minuses in both of these equations. It always has to be minus. If you see a plus, you can actually rewrite that as minus a negative, which is going to be important in just a bit. Next, let's take a look at the center. Right here we need an h. So the h comes from the center. This is a -2. Right, so don't use this negative as the negative for the -2. Right, there's going to be 2 negatives here, so please be careful with that. And then for our k, we have -3. Alright, so now let's do a little bit of math. So this becomes plus plus, 1 plus 2 is 3, Right here, again, two negatives become positive, so 4 plus 3 is 7. And if we can just simplify that, we'll know what our radius is. So 3 squared is 9, 7 squared is 49. Alright, so if I add this up together, I have 58 is my radius squared. And what I need is my radius squared, right? This is what the formula calls for. So when I go write this formula, all I need to do, anytime we're writing the equation in standard form for any of our conics, is we're going to leave x and y generic, right? Because if I plug in a value for x and y, then I'm being super specific about only one point on the circle. Right? And what I want to do is I want to write an equation where I could actually find any of the infinite points on the circle. So I want to leave x and y just as x and y. So this is just x, even though I know one of the x's and I know one of the y's. I don't want to be specific, I want to be general in my answer. I want to cover all the possible answers. Alright, so the center, I'm going to have a minus a negative 2. So if I have a minus negative 2, that's a positive 2, right? A minus minus. And then don't forget to square it. It's easy to forget. And then for my k, I have a minus negative 3. So that becomes plus 3. And again, don't forget to square it. Your x should always go first, your y should go second. Alright? And then we have our r squared, which we figured out down here is 58. You don't need to square 58. 58 is already squared. Right? If I wanted to find what the radius was, I'd have to square root this. So this is the standard form equation of the circle that has a point of 1, 4 and a center at negative 2, negative 3.